Hello, good morning. My name is Kendi Babula and I'm a graduate of Aircraft Maintenance Engineering right here from the College of Aviation Technology, Zaria. In this short video, I'll be sharing with you my latest project, which is a fly-by-wire based flight control teaching aid. This flight control teaching aid comprises of the primary control surfaces as well as the cockpit controls. The cockpit controls consist of the rudder pedals and the flight stick, which is in this case the joystick, while the primary control surfaces consist of the ailerons, the elevator and the rudder. But before I go into the technical details of this project, I've always had the flair and the passion for electronics engineering. Anything that has to do with electricity, anything that has to do with electronics has been my passion right from some DIYs up to writing codes that will help in developing a particular prototype. From as little as codes that take some few minutes down to codes that has to do with several lines, several hours of debugging and several hours of implementation has always been what I find interesting, and I found joy in doing these things. I've had an interesting work with positional servo motors, and interestingly they can be used to do many things, right from just using them as toys down to implementing them to be robot arms and so on and so forth. Hence the inspiration for this project. Going into the working principle of this particular model, it is as simple as ABC. Now we have the cockpit controls. These cockpit controls are what the user used to operate this particular flight model. Since it is based on a fly-by-wire system, it is safe to say that it flies by wire, meaning that it flies basically by signals, electrical signals that pass through electrical cables. From the rudder pedals, which make use of Hall effect sensors, it is used to control the ruders and also to control the yawing movement of the aircraft, down to the flight stick, which make use of potentiometers, and it controls both the Y and the X axis, which is the roll and the pitch axis of the aircraft. This is achieved by moving the ailerons and the elevator in a particular orientation for you to have the desired position of that aircraft. Now, a special feature to this particular prototype is that it can be manipulated to assume a particular position for an undefined period of time until you change the position. This is called the lock position. The lock position enables whoever uses this as a teaching aid to position the aircraft in a particular attitude for further explanation or for further illustration of how the aircraft will behave while on air. Now, one can ask, how is it possible for you to achieve the attitudinal movement of this particular model in relation to the cockpit controls and also to the primary control surfaces? It's that simple. Larger servo motors, which have much torque capacity compared to those used on the primary control surfaces, are implemented in these ways. 3 of them are used. One controls the roll movement, another controls the pitching movement, while the last controls the yawing movement of this aircraft. These 3 servo motors are assembled in a way and manner that it fits to hold the aircraft in a particular pivoted in a particular position until the desired movement for that aircraft is being imputed. The interfacing of both the servo motors on the control surface, the servo motors that control the attitudinal movement of the aircraft, and the cockpit control is achieved by one flight computer. This computer is being mimicked by a microcontroller in this case. A microcontroller which is embedded on a development board called the Arduino is used coupled with some codes embedded on the microcontroller to be able to achieve this by converting whatever analog input, whatever electrical analog input is received from the cockpit control to control the primary control surfaces and the attitudinal movement of the aircraft to the respective and desired position of the user. Finally, what is the importance of this particular project to the aviation industry or to the aviation educational sector? How can you bring the aircraft down to the classroom and have it behave as if it's in the air? And I just thought of creating a model that would simulate in real life how this attitude of the aircraft move in relation to the controls being imputed by the pilot, hence the creation of this particular model. Of course, so many improvements can be made on this particular model, in the sense that it could have implemented on its flight instrument, which has to do with the attitudinal movement of the aircraft, the attitude of the aircraft. For example, the artificial horizon, the turn and bank indicator, and so on and so forth. My name is FBW, and thank you for watching.